So yesterday we talked about when it was in the form y equals a b to the x. Remember, no transformations on it really, just the a b to the x. Your a technically is your vertical stretch factor, but we didn't really get into that as much. If it was just in the form y equals a b to the x, no transformations really on it, what was a always? Your y-intercept, because if I plugged a 0 in for x, b to the x became a 1, right? This would be b to the 0. So your a was your y-intercept only in that form, though. It has to be in that form. If there's like a plus c at the back, something like, then it throws it right up. Okay, it has to be just that form. So today we're going to look at, okay, that's a parent function, great. What happens if I add some transformations to it? So in transformed form, we'll go from y equals c to the x to y equals a c b x minus h plus k. Now the key thing with exponential functions is the bases have to be the same or you can't compare them. So for example, if I had like y equals 3 to the x and then I had y equals 3 to the x minus 4, these are both base 3, so I can compare them. If one was a 3 and one was a 7, they couldn't ask me to compare them. They won't ask me. Some people are like, what if they do? They won't. If it's a 3 and a 7, you can't make them the same. Okay? Those bases will appear nowhere in your statement of transformations. That's just the parent function. The parent function is 3 to the x. It now is this. So the 3's, the base 3's, appear nowhere. That number appears nowhere in vertical stretch, horizontal stretch, reflections, translations, nowhere. It just has to be the same. Okay? Now the a in front is your vertical stretch and your reflection in the x. Your b is your horizontal stretch by 1 over b. It always flips. Like, when doesn't it not? It always flips. It just does. This would be your horizontal translation and your vertical translation. So if it's with the x, it affects the x. If it's in front or at the back, it affects the y's. Nothing changed there. So if you're really good at transformations, today's lesson, super easy. It's just translations. Transformations over and over and over. We're going to do a log function, graphs, and then we're going to do log transformations. We're going to do trig transformations. Like, the transformations don't go away. Okay? So here it says, we're going to describe, but we're also going to do mapping, because we always do mapping and descriptions together just so we practice them, because they're always the same numbers, right? So describe how the graph of the second function compares to the graph of the first function. So we have y equals 4 to the x, and we have y equals 2, 4 to the x minus 2. First thing we always have to check for is if there's, now we have to check an extra thing. We have to make sure that there's a common base, but we also have to make sure that it's in y equals and that there's a 1 in front of your x, right? That didn't change for transformations. Remember how we always have to have a 1 in front of our x, and we have to have it in y equals? That doesn't change. It's still transformations. The only thing that changes here is this base has to be the same as that base. And they are. We see that, right? Is that 4 appearing anywhere in our transformations, in our SRT? No. The 4 just needs to be the same between the two. Then we go to our stretches, reflections, translations. So our stretches. Is there a stretch? There's a number in front. What kind of stretch do you think that is? Yeah, it's a vertical stretch. By a factor of 2 about the x-axis. Is there a horizontal stretch? Is there anything in front of the x? No, there's no horizontal stretch. Is the number in front of the x? It's a 1, so no reflection. And the 2 is a positive, so no reflection. So our reflections would just sit. Great. We'll leave them sit. Translations. I have x minus 2. It's with the x, so it's a horizontal translation. Yeah. Horizontal translation, 2 units right. When I go to do mapping, I'm going to go x, y becomes what's here affects my x's, and then here and here affects my y's, right? So my x is, I'm going to do what to it? I need to move it to right, so I'm going to plus 2. And then my y's I'm going to multiply 2y. I'm going to get you to do B. But first we're going to get into y equals form in a form that's helpful to us. So right now, what's my problem? The y is not by itself, so I need to subtract the 4. So I'm going to get y equals negative the 2. The negative's not with the 2. If the negative was with the 2, it would be in a bracket. Is it in a bracket?
No.
No. So 2's by itself. So it's negative 2. Now, x over 5. How else could I write it? Because x over 5 is confusing.
1/5 times x.
Yes, 1/5 x. And then minus 4. Now you try it. Give me SRT. Okay, so this one, do I have any stretches? Yep. I have a 1/5 sitting in front of that x, correct?
Yeah.
So I have a horizontal stretch by a factor of 5 about the y-axis. My r is a reflection. It's sitting in front, so I have a reflection. It's with the y, so I have a reflection in the translations. Yeah, vertical translation. More units down. Mapping x, y becomes, so the only thing that affected my x was this 1/5. So I'm going to get 5x. And then I have a negative y minus 4. Now example 2, I told you that they have to have the same base, or I can't compare them, correct? Base 3, base 3, base 4, base 4, base 2, base 2 in this case. They have to be the same base or I can't compare them. Now I said they'll never give you like base 2 and 7 because you can't make them be each other, correct? But they can do what we did here in example 2. Example 2 says, explain using transformations why the graph of 1/3 x is a reflection in the y-axis of the graph of y equals 3 to the x. So we have y equals 1/3 x. And then y equals 3 to the x. We're going to use grade 10 exponent laws to explain this. So let's think about it first. Say we're stuck. We know that a reflection in the y-axis means what in the equation? Yeah. There's a negative x. That's what we need. Correct? We need a negative x, and that would prove that there's a reflection in the y. We agree? Currently, I can't compare them because I have 1/3 and I have 3. I told you they're not going to give you like a 2 and a 7 or a 3 and a 4. Like, you can't make them be the same base. But obviously, you can make these ones be the same base or I couldn't ask this question. Correct? So how can I make 1/3 be 3? And remember, we just said this. In order for there to be a reflection in the y, I need to have a negative x. Right? So what base could I make them both be? Make them both be base 3. So, how can I make 1/3 be 3? Oh. We need it to be a negative x. Yep. That was just vicious. I really hope that was not picked up. Yep. Sorry. Not you. Not you at all. You're good. Please answer me your question.
Oh, well, I was going to answer the question.
Yep, that's what I wanted. That was something else in a different sandwich story somewhere else. That was a problem. Okay. Maybe it's just someone was not happy. But you're fine, Sean. Carry on. Okay, tell me what happened.
What do you mean what happened?
Well, you were
What do you
going
mean what happened? I was going to what are we? Can we just make
to... Yes, please. Yeah, you put it 3 to the power of -1. There we are. So, y equals... I have no idea what's going on. 3 to the power of -1 to the x. 3 to the power of -1 is a third. 4 to the power of -1 is a quarter. 7 to the power of -1 is 1/7. Right? So if you want to make them the same, what you can do is you can flip them and raise to the power of -1. So 1/3 flipped is 3 over 1 to the power of -1. So we have y equals 3 to the -1x. And now we can actually compare them. They both are base 3. The only difference is this has a -x and that one does not. Correct? So what does this mean? There's a reflection in the y-axis. Sorry? Yep. You could change the 3 to a third by making it to the -1, and then you compare a third and a third. The bases just have to be the same. Whichever route you go, doesn't matter. So for these ones, we're going to find the x and y intercepts. We're going to use our calculators. For now, we're going to learn how to actually solve them, the x-intercepts properly using logs later. But we're going to state the x and y intercepts. Now, y-intercepts are easy. Why are y-intercepts easy? You make x equal to 0 and solve. So the y-intercept is easy. So it's going to be f of 0 equals 2 to the 0, which is 1. So it's at 0, 1. This one's going to be f of 0 equals 2 times 10 to the 0. 10 to the 0 is 1, so it's 2 times 1, which is 2. So this one's going to be 0, 2. Okay? You do C and D. And then go to your calculator and try and get the x-intercepts if they exist. There we go. I don't know what I want to record. I don't know if I want to delete it. I don't know. Vertical translation equals the vertical asymptote. So in this case, all my vertical asymptotes are y equals 0, y equals 0, y equals 0, y equals 0. Y equals 0 is the x-axis, which means that there's a dashed line that doesn't exist, where the graph doesn't exist, sorry, on the x-axis. So these have no x-intercept. So all of them. For 4, let's look at A. A says, describe how the graph of the second function compares to the graph of the first function. In order to compare them, we have to have the same what? Base. So this is base 10. This is base 10. That makes me happy. Is 10 going to appear anywhere in this transformation? No. The only thing that's going to affect us here is we're going to have a negative in front of the 1 and this minus 3 at the back. We agree? Are there any stretches? No. Are there any reflections? Yes. There's a reflection with the x, so it's a reflection in the y-axis. And then translations? Vertical translation, 3 units down. I want you to tell me the vertical or the horizontal asymptote. The horizontal asymptote's normally at y equals 0. Where is it going to be at this time? Y equals -3. Because the only thing that can move a horizontal line is a vertical translation up or down, correct? And that horizontal tangent at y equals 0 has been moved to 3 down. So now instead of it being at y equals 0, it's at y equals -3. We're going to discuss the range as well. Our range of all the functions yesterday were we had an asymptote on the x-axis and our range was greater than or equal to 0. We agree? What did I tell you? What's the only thing that can make it be less? Negative where? In the y, because I need a reflection in the x-axis. It's range, right? What's the only thing that can change range? Things that affect y's. We agree? So there has to be a negative in front in order to change my inequality to be less than. Remember, it's either greater than or less than. If I don't have a negative in front, it's greater than the asymptote. If I have a negative in front, it's less than the asymptote, correct? Do I have a negative in front here? No. So my range is easy. It's going to be y such that y is greater than, because it didn't flip, there's no reflection, greater than what? -3 YER. So if you can get the asymptote and you see there's no reflection, it's just greater than the asymptote. It can't be equal to, because that's where the asymptote exists, which is where the graph does not exist, right? So it's greater than or it's less than. Okay, let's look at this one. Can I compare them as they currently are? No. I want to change the half to a 2. I don't want to change the 2 to a half because that's the original. We always want to change the new to the original, correct? So how can I make this be, it's going to be 5 and then 2 to the -x. This is true. We don't have to say transformations, we're just going to talk about them. What are the transformations on this one? First, we have to say something else. There's a vertical stretch by a factor of 5 about the x-axis, and there's a reflection in the y-axis. We agree? We're not going to have straight, we've done transformations above, we're not going to do that here. I want you to now give me this. I want the horizontal asymptote. Horizontal asymptote's at y equals what? 0, because it's always equal to our vertical translation. In this case, it is nada, 0. My range will always be greater than the asymptote unless there is a reflection with the y's, right? Because if y has to affect my range, step in the bracket affects my domain, step outside affects my range, right? Is there a negative in front of that 5? No. So my range is going to be y such that y is greater than 0. Y-E-R. For C and D, I do not want you to state the transformations that it says above. I don't want you to describe them. I want the horizontal asymptote and the range for both C and D. So this one I would have to change to be y equals 6 to the -1, correct? There's already a negative x there. What happens? It becomes a positive. There are no transformations. It's actually the exact same graph. Okay? So, still though, I'm going to have a horizontal asymptote. What's my horizontal asymptote at? 0, because my vertical translation is nothing. There, nothing happened. Horizontal asymptote, y equals 0. And then my range? Yeah, y such that y is greater than or equal to 0, YER. I'm going to use interval to show you now the difference. So if it's greater than or equal to 0, that's from 0. It's equal to, it's not equal to, Lepp. Grab a mitt, get in the game. Alright. I hashed my own self. Okay. So it's going to be round bracket because it's not equal to, and then it goes to infinity. D, that's the same as saying y equals a to the 1/2 x. Is that in any way affecting my asymptote? No. So this, still going to be that. This, still going to be that. Didn't change. Have same asymptote, same range. Then we're going to flip over. We're going to go to example 6. It's a multiple choice. Which equation represents an exponential function? That was a common error. A is a polynomial, not an exponential function. B, have we ever used a -3 in there? I said if it was between 0 and 1, it was decreasing. It was a decreasing function, right? Yesterday we talked about that b value. If it was between 0 and 1, it was decreasing, like a half or a third, correct? But if it was greater than 1, so 1 to infinity, it was increasing. We agree? Did we ever say b could be negative? No, this is not an exponential function. Okay, what about D? It's in the denominator. Is that helpful? No, it's actually a rational function. You learned about those last year. And then C is an exponential because this 2 below, I could just write out its front as a what? This 2 below, I could write it out in front as what?
1/2.
1/2, yeah, 1/2. Which is an exponential function. I want you to do 7 and 8. Go. Okay, example 7. Which equation determines an asymptote of 3 to the x minus 2 plus 1? It's y equals C. Y equals 1. Because it's just your horizontal or your vertical translation. Okay, the domain and range. The domain of this function is going to be x such that x is an element of the reals. Or an interval, that's set notation. An interval notation, negative infinity, positive infinity. My range, is there any reflection in an x? Is there a negative in front with my y? Is my inequality sign flipping? No. So it's going to be y is greater than 3, y-e-r. Or an interval notation, round bracket 3 to infinity. The x and y intercepts. Well, this is a normal base function not reflected and shoved up 3. Are there any x-intercepts? No. Yes, the x-axis is now free. However, the asymptote is at 3, and the entire graph's above that, so there's no x-intercepts. Y-intercept people are still using their calculators for, but to be honest, it's just easier to do algebraically, and there's less mistakes. So if we do f of 0 equals 5 to the 0 plus 4 plus 3, what do we get? What's 5 to the power of 4 plus 3?
628.
Yeah. Alan? No. Was that you or was that Ryder? No, the other. That was good. I was happy with that.
I didn't say anything.
Oh, it was Ryder.
It was one of them two.
It was Ryder. Oh, it was Ryder. Your name's not Ryder. It was Ryder. Yeah, because your name's Austin, hence why I said it. You're right. All right. The silent one was the one who was the problem. Okay, the equation of the asymptote. We have to write horizontal asymptote. You have to tell what type it is. At y equals 3. What's the asymptote on this graph? It's a horizontal asymptote. At y equals negative 1. I'm going to change this up. I'm going to put a negative 1 in front of here. What's going to happen to my range? It's going to be less than negative 1. YR. Okay, your assignment. Homework. I don't know. That's your homework.